Hello students, today we are going to discuss the solid state, liquid solution and nuclear chemistry as a part of the JEE ADV advanced preparation for 2023. So today is the sixth session at our That's It YouTube channel. Me, KASU sir, going to discuss the concepts related to these chapters by using the PYQs. You know that solving the PYQs is not a simple task unless you are thorough in the fundamentals. So in every session I am trying to solve at least 10 to 15 or even 20 questions and trying to explain the concepts or the idea wherein you can solve the questions very easily. So let's start the day with the solid state questions. Like you can see that the questions which are asked from the solid state are usually the concept oriented, where every lattice will be clearly mentioned and you have to answer the question based on your visualization power, right? Not imagination power. You should have the visualization power. I mean to say that when a lattice is mentioned on a 2D paper, you have to absolutely visualize where the atoms or the ions are located by looking around the room where you are sitting, because the room in which you are sitting is assumed to be a cube, and most of the questions which are asked in JEE advanced or mains are so far from the cubic lattices. Hence it is very easy for you to imagine the room as a cube and solve the question accordingly. Like you can see that atom X occupies the FCC lattice as well as the alternate tetrahedral voids of the same lattice. That means the lattice size atom is only present at the tetrahedral void, but since it cannot fill all the tetrahedral void, it is occupying only the alternate tetrahedral void. That is the logic, isn't it? Now the packing efficiency of the resultant solid is being asked. Right now you should have the idea how the atoms are placed. For that I have taken the zinc blend structure as a reference, because you know in that the atoms are not only present at the corners and the face centers, but also you can see that they are present at the alternate tetrahedral void. That means you know that tetrahedral voids totally in FCC lattice are 8, in that 4 are being filled by the same atom. Here this is not the ZNS type of lattice where the cations are occupying the voids. Here the lattice size atom is only occupying the voids, right? So now you can see that if you want to find the packing fraction, the resultant, the packing fraction, you need to have the number of atoms that are effectively present in the lattice 4 by 3 pi r cube upon a cube, right? So this is how we are going to find the packing of the particular crystalline solid, right? Now we have to get the z value here, isn't it? And the relation between A and R to solve this question. Now let's focus on the number of effective spheres present in this lattice. You know that this is occupying the FCC as well as alternate tetrahedral void, isn't it? Now FCC means the atoms are present at the corners and face centers. You know that, isn't it? So the atom that are present with respect to the FCC lattice positions are 4, and alternate tetrahedral void. You know that the tetrahedral voids are 2 times the FCC lattice positions, that is 8, but out of which only 4 are occupied. Therefore the total number of spheres that are present are equal to how many? 8. Now we got that value. Now we have to look into this thing, right? You know, for that I would take the body diagonal into consideration, right? If you want to solve this question, you should have the idea about the tetrahedral position, isn't it? So I am going to pull it little bit onto the body diagonal. Now you know that this FCC lattice is distorted. Why am I saying this? Is because in the void, in the tetrahedral void, the void size atom is not kept. The lattice size atom is kept. When lattice size atom is kept, you know that it is not going to fit into the voids, hence the distortion will take place. Therefore it is absolutely wrong saying that 4 are equal to root 2a. That relationship is gone. Because of what? Distortion. What is the reason for this distortion? And then how could I know the relation between A and R? Now you see, this is the body diagonal. You know the length of the body diagonal is root 3a, and you know where exactly this tetrahedral void is located. It is located at 1/4 the distance from the corner of the body diagonal, isn't it? Therefore 2r, that is r plus r, is equal to root 3a by 4. This implies A is equal to 8r by root 3. This is the actual relationship between A and R. Remember, not this. Therefore, packing fraction is equal to number of spheres into 4 by 3 pi r cube upon A cube. A is nothing but 8r by root 3 whole cube. Now, irrespective of the size of what you call the atom which is occupying that lattice, you will be finding out the packing fraction. Hope you can solve the question, isn't it? Right? So you have to solve it. Calculation I am leaving it to you, isn't it? Now you see another beautiful question asked from the JEE Advanced. Now you can see this is made of cations X. You can see where the cations are present, isn't it? Now they are present over here. Look at it carefully. And anion Y, right? Anion Y is actually at the corners. Right? Now the packing efficiency is asked after giving the diagram, right? One gets a feeling that this is the FCC lattice, but this is not purely FCC lattice. Of course, this is face centered. X which is present along with the corners which are present, right? Corners are Y and the face center atom is X. So this is not FCC lattice, because you know that in FCC lattice the corners do not touch each other, that is A is not equal to 2R. However, here you can see A is equal to 2R minus, isn't it? Because the corners are in contact. So this is not FCC lattice. Now you have to find out the packing fraction. You know that this is present at the face center. So now let's talk about what you call the anion Y, which is occupying the lattice position, that is the corners. Anion Y is occupying what? The corners of a cube, that is 8 into 1 by 8. That is equal to how much? 1. And when it comes to the cation, am I right? You can see that cation, which is nothing but X smaller, is present in face centers. So how many faces are there? 6 into half is the contribution, that is equal to 3. Therefore, when you write the packing fraction, you can see there are 1 corners r minus whole cube plus 3 cations 4 by 3 pi r plus whole cube divided by A cube, isn't it? Now we can see that A, when you are getting the value of A, you can take this length. I meant to say the length of the face diagonal into consideration. Alright. So you can see based on that, I can draw a relationship between this is your R minus and this is your R plus. So you can see that R minus plus R plus is equal to A by root 2. That means half of the length of the face diagonal. Alright, so you can see that A is equal to how much? Root 2 into R minus plus R plus whole cube. Now we have to get rid of this R plus and R minus. For that, you can see this is present in the square planar void. Where is your X is present? Square planar void, right? For square planar void, the ideal radius ratio, that is R plus by R minus, is equal to how much? 0.414. Therefore, R plus equal to 0.414. R minus, which I am going to substitute here. What do I get? I am going to substitute R plus in terms of R minus, plus 3 got cancelled, 4 pi, R plus as what? 0.414 R minus whole cube upon root 2 into R minus I am substituting in terms of R plus I am substituting in terms of what? In terms of R minus, that is 0.414 R minus plus R minus whole cube. you can see that your R minus is being taken common in all and it gets cancelled, and you will get a standard value for the packing fraction. The only point is that you need to identify that there is anion contact in this lattice. This is not FCC. Alright, so this is one of the interesting questions. What do you say? All the questions that are asked from this chapter are really beautiful, right? Let's see the next one. You can see there is a solid Mx, right, which is having the X minus ions as well as the M plus ions. You can see that you have to construct a new crystalline structure Z or Z whose unit cell is constructed from the unit cell of Mx from the following sequential instruction given below. You can see remove all the anions X, that is X, except the central one. You can see central one is actually the octahedral void. That clearly indicates that anions, right, anion which is equal to X minus is present in the octahedral void. So this is the beauty, right? Anion is present in what? Octahedral void. And the cation is present in FCC lattice position. You know that NaCl lattice, right? You know the opposite to NaCl lattice is being taken, because you know that in NaCl lattice the cation is present in the octahedral void. The anion is being taken in the octahedral. How would I know that? You can see that except the central one is nothing but the octahedral void. So they indicate indirectly that X is present in what? The octahedral void. So don't make a mistake of taking this X minus as lattice positions of FCC. And you know, cation, this is X minus and this is M plus. Cation is present in FCC lattice positions, right? You know, FCC lattice position. Now you can see, you can carefully sort out the data, the information which is given to us, isn't it? Now you see what we are exactly trying to do in every case when we are given this lattice. You can see the first one. When I say that it is octahedral voids, you know that octahedral voids are present at the body center and on all the edges, isn't it? 12 into 1 by 4. That is equal to 1 plus actually 3, which is equal to 4. And FCC lattice positions are corners, that is 8 into 1 by 8 plus face center, 6 into half. This is equal to also what? 4, right? This is the basic information what we have. What we are doing is we are removing all the anions except the central one. We are not making any changes with this. This is remaining as 4, but we are removing all of them except 1. So I am removing all the 3, so I am left out with only 1 now, right? This is your first information. It is not confusing. Question looks to be a bit confusing, but absolutely straight. Now you can look at the second data. Replace all the face centered cations M by the anions, right? You can see that the face centered cations are actually, you know, this is equal to 1 plus 3, right? So you have to replace all the, so here in the first step you have removed all the anions X except the central one. That means these 3 are removed, only 1 is left out. In the second place, the second step what you are doing, replace all the face centered cations, right? All the face centered cations by the anions. So what it has become now, you can see the anions have become 1 plus 3 and cations have become 1. You have replaced, no? Replacements means the number of anion increases and that of cation decreases, isn't it? Beauty. In the next step, you see what you are doing. Remove all the corner cations. Boss, only 1 is left out. That is nothing but the corner, isn't it? You can see the 1 is left out. You know, he is asking you to remove that also. The total of the anion are 4 and that of cation are only 0. Now you can see in the last step what you are trying to do there. Bottom line, the last step. Replace the central anion with a cation. That means what? There is one cation which is kept out of 4, that is 1 plus 3. Now he says that this 1 has to be replaced. That means how many are remaining? 1 is removed. That means how many are remaining? 3. Therefore, what is being asked? The value of the number of anion. You can see number of anions. Finally, you have been asked to find out the ratio of number of anions upon the number of cations is turning out to be 3 by 1, which is equal to 3. Such a beauty, right? Isn't it? The questions of JEE Advanced are absolutely stunners. They give you the goosebumps while solving, isn't it? But you need to have a control. Like you could see that the cubic crystalline structure having the cation M and X at respective position. Like you could see the lattice that M is actually present at the face centers, that is 6 into half, which is equal to 3, and X is actually present at the edges, isn't it? Edge centers, which is equal to 12 into 1 by 4, which is equal to 3. Therefore, you can see that the empirical formula of this will be mx, as the unit formula is m3x3. So, this option looks to be okay. And one more thing, that the cation M and anion X have the different coordination numbers. Let's see that whether that's true or false. For that, I would like to extend this lattice little bit. Alright. Carefully observe how beautifully the questions are being framed. Now you see, I am extending this lattice to a certain distance, where again I will find these X minus anions, right? You can see that there is a connect between them. Now this is the lattice that I am talking about. Now you see, when you extend it up front, alright, so you will be getting this lattice. As you could see that this appears like a body centered cubic lattice, isn't it? You can see that it appears like cesium chloride kind of lattice. In that, that the cesium ion touches all 8 corners and the chloride ion touches all 8 body centers. So that's called 8:8 coordination geometry, but not the different geometry. Therefore, this statement is false. And when it is cesium chloride type of lattice, the radius ratio of the cation anion is 0.732, but not 0.414. This looks to be also incorrect. Now the ratio of mx bond length to the cubic unit cell edge length is 0.866. Beautiful question, right? Now you can see we need to reach out till this point. I mean to say that the x minus to the m plus, right? This distance I'll call as some d. What is that? D. You have to reach out there, right? First of all, you have to reach out till here, and this distance is nothing but a by 2, corner till edge center, right? And from here you are reaching out to the face center. This is equal to a by root. So if I apply Pythagoras theorem to find out d, that you will get d square is equal to a by 2 whole square plus a by root 2 whole square. So d square, how much, is equal to a square by 4 plus a square by 2. Alright, so d square by a square is equal to how much? 3a square by 4, or d by a equal to maybe 0.866. I am not sure about it. I want you to cross check that value. Alright, so if that is correct, then the right answer for this question is also C. This beautiful question was asked in JEE Advanced, one of the best question. Now these are all the questions which were asked in JEE Advanced from solid states. You can make out clearly what kind of questions are asked, how the lattice structures are. Alright, and lattice structures are given. Slightly confusing factors are there here and there, so don't get panicked by looking at those factors. You should have the pure visualization power to solve the question from solid state, isn't it? Now you see the question is from nuclear chemistry or radioactivity question. You can see that uranium 92-238 is undergoing the decay to give you lead 82-206 plus alpha particle, and beta particles are also emitted, obviously. Like you have to balance with respect to the mass number, because that beta particle doesn't contribute to the mass number. So alpha particle 238.6 means there 206 means there should be 32 lacking, that is 8. And now you can see 82 plus how much, 16, no, 98, and there are 92 uranium, therefore there are 6 beta particles. First you have to balance it, because you have to get the mole ratio of the alpha particles versus the parent nuclide. You can see what information you are given. You are given that the initial mass of the uranium 238 is given, and number of nuclides, number of alpha particles are given, right? So you have to better convert this into moles, right? Initial moles of uranium is equal to what? Weight upon atomic weight, which is equal to 238. Now it's being given that the number of half-lives, that value of n is equal to 3, and number of alpha particles which are obtained after 3 half-lives, right? After 3 half-lives, you have to write the scenario or situation here, right? Now after 3 half-lives, you can see that the number of alpha particles which are obtained are z into 10 to the power 18. Alright, so you have to convert that into moles by writing it with this 6 into 10 power 23 Avogadro number. So you got the number of moles of alpha particle. You can see for 8 moles of alpha particle, 1 mole of the uranium had reacted. Therefore, the number of moles of uranium reacted is 1 by 8 times of this whole value according to the stoichiometry or mole ratio. These are reacted moles of uranium. How much you took initially? This much. So remaining are the difference, isn't it? So this is nothing but your final moles. Now we know the formula, isn't it? Nt is equal to n naught into 1 by 2 whole power number of half-lives, which is given in the question as 3. Now when I substitute the values, calculation is bit length here, but question has simple concepts only. And 10 power 18 divided by 6 into 10 power 23 is equal to the initial moles. This is your Nt, and initial moles are n naught by 238 into 1 by 2 whole cube, that is 1 by 8. So I want you to get the value of what? Z from this. Hope you will solve this simple question. Calculation, I am leaving it to you. I did not expect that JEE Advanced will ask any such type of easy questions also. You can see that 238 changing into thorium 90 234, 91 234, 234, 90 230, isn't it? Now you can see you have to write the changes, right? As you can see that in the first process, the difference is in the atomic number as well as mass number. You know that beta particle contributes only to the atomic number but not mass number. So here both are taking place, means it is alpha particle which is emitted in this process. And here you can see that there is no difference in the mass number. However, the atomic number had changed by 1 unit. So that means it is emitting beta particle. As that you could see that it is mass number is remaining same, obviously, then this might have been the beta particle as well. And 92 to 90 and then 2 units of decrease in the atomic number, 4 unit of decrease in the mass number is again alpha particle. You can see that this particle is x1, this is given as x2, this is x3, and x3 is a gamma ray. That's wrong. X3 is a beta particle. Z is an isotope of uranium. You can see same atomic number, different mass number. This is true. X2 is a beta particle. Yes, this is also true. X1 will deflect towards, what is X1? Alpha, towards negatively charged plate, because you know that this is positively charged species. So this is also true statement, right? More of JEE main kind of question. Sometime it happens, right? Let's quickly bounce to the liquid solution questions, where some questions were found to be very easy, formula oriented, and some of them were little bit tricky. If I could analyze the previous questions which are asked from the liquid solution chapter, some of them are easy, some of them are difficult, but you should have that patience to solve anyways, right? You can see that the weight of the non-volatile solute is given in a certain weight of the solvent, and vapor pressure is decreased from 650 to 640, and depression in freezing point is asked, and you have been given that the molar mass of benzene is 78 and the freezing point depression constant, that is Kf value, is given, right? You're given this value, you are tempted to write what? P naught minus P by P naught equal to what? Xp, relative lowering of vapor pressure, right? 650 minus 640 upon 650 is equal to what? Xp. But you have to end up at the depression of freezing point, isn't it? You have to find out the depression of freezing point. For the formula is delta TF equal to non-electrolyte type, so I value equal to 1. Kf into, that is Kf value is given as 5.12 into molality of the solution. You know the relation between molality and mole fraction, xb by 1 minus xb into 1000 upon molar mass of solvent is nothing but molality. Now, anyways, you got the value of xb. Please substitute it over here. And molecular weight of the solvent is given as 78. You please find out the molality and substitute here to get the depression of freezing point. It's a simple question. Directly I have given you the lead here so that you can easily solve this question, right? You can see 10 by xb is equal to what? 10 by 650 divided by 640 by 650, isn't it? Into 1000 divided by 78, which is equal to molality, right? 650 got cancelled. 1 by 64 into 1000 by 78 equal to molality. I want you to substitute this value over here and get delta TF for the question. Direct question, formula based question. It's more of NCERT kind of question which was asked previously. Let's see the next one. An aqueous solution, we have to interpret the data. Data science is very important here. You can see that number of moles of the ionic salt, that is NB, are given. So weight of solvent is also given in kilogram, and the salt remained 90% dissociated. Alpha value is given. The vapor pressure is PA, and the pure water is P0. And you have to find out the number of ions, right? You know that if I assume number of ions per formula unit equal to some n, you have studied the Van 't Hoff factor equal to what? 1 plus n minus 1 into alpha. This we have derived long back. Alright, if you follow my videos, you will see how this derivation come into picture, right? You can see that alpha value is also given. Now you need to solve this question, right? For that you have to take this value. What is that value? You need to take into consideration, right? What values are given here? Just carefully observe, right? So you can see that P0 minus P by P0 equal to XB. That is number of moles of this thing solute by total moles, that is 0.1 plus 1.8 kg, that is 1800 grams by 18 into I, right? Into 1 plus n minus 1 into alpha value is given as how much? 0.9. Right? You have to solve this simple question to get n. The number of ions present per formula unit you can obtain, isn't it, right? Easier question. What I felt is easy. I don't know about you. Questions are little bit formula oriented from this chapter, right? Like you could see in the next question that liquids A and B are forming the ideal solution. There are two liquids, isn't it, right? You need to be careful. And you have taken a temperature T equimolar binary solution of liquid A and B. You can see that this value, that is total pressure, is given, right? This value is the total pressure. And equimolar, that means the moles of this A and B, let's say, is X. Now at the same temperature, a new solution of A and B having the mole fraction XA and XB respectively has a vapor pressure of 22.5. Now this is the changed value. Now you see in the first case, equimolar when moles are being taken, when equimolar moles of A and B are being taken, that means you will get the total pressure as, that, right? For an ideal solution of two miscible liquids, you will be getting PA0 XA plus PB0 XB as the total pressure, right? So now I will be substituting here that the total vapor pressure is 45 is equal to PA0. You can see that is given as 20 torr. So PA0 is 20 into XA, that is moles of A by total moles, plus PB0, that you need to find out from here, into X by total moles. So as you could see that the 45 is equal to 10 plus PB naught by 2. So like you could see that the value of PB naught equal to 70. Now we can see in the other composition where the mole fractions are these, the vapor pressure is 22.5. Now your 22.5 equal to PA naught does not change, 20 into XA. What do you have to find out here? XA by XB, isn't it? 20 into XA plus PV naught, that is 70 into XB, that is 1 minus X. That's it. So you got it, right? 22.5 is equal to 20 XA plus 70 minus 70 X. So 50 XA equal to how much is this? 47.5. So you got the value of XA, right? 27.5. 47.5 divided by 50, and you know XB is nothing but 1 minus X. So you just find out the ratio of XA by XB, that is 47.5 upon 50 divided by 2.5 upon 50. So there lies your answer, right? Looks to be simple, right? Again, formula oriented, more of less logic, more formula, concept is less, formula is more dominating. Now you can see for a solution formed by mixing two liquids, again ideal solution, two liquids, miscible liquid, the vapor pressure of L is plotted again the mole fraction of M, like you know in A and B graph, right? You know x1 and x2 are representing the mole fraction of L and M respectively. The correct statements are, you can see the first sentence, the attractive intermolecular interactions between LL in pure liquid L and MM in pure liquid M are stronger than those between LM interactions. Okay, so he means to the other positive deviation, like you know when you compare this non-ideal case with the ideal one by drawing the parallel graph for the ideal one, you know that this case is greater, right? Real is greater, the value were found to be greater, so that means it is positive deviation case where vapor pressure increases. You can watch my video, 1 minute short video on this, right? You know, positive deviation case. So what will happen here? The vapor pressure increases. Why does the vapor pressure increase? Because the new interactions are weaker than old interaction. What are the older interaction? MM and LL. So this seems to be that MM and LL are stronger or ML is weaker. So this looks to be correct. Alright, now let's see the other values, right? You know, you can see that the other values are simply complementing, right? You know, you can see that I'll write the value for the total pressure P equal to, right? You can see that graph, right? P equal to PA naught XA plus PB naught XP, right? Now you can see that what else is given here? PL equal to PL naught XL, alright. So PL naught into 1 minus XL. Now you can see that at XM tends to 0, XL tends to 1, right? Alright, you can see that the PL value equal to here from this expression, right? So when XL tends to 1 or XM tends to 0, the point Z represent, right? You can see that this is M tending towards 0. So or XL tends to 1, the condition which I have applied, so you can see PL, that is the vapor pressure, is nothing but the vapor pressure of pure liquid when XL tends to 1. So option C looks to be the correct answer, which is matching to this question, isn't it? When it is matching with C, it doesn't match with B and D. You please carefully look at it. Is it matching? No. The point Z represents, no, it is not matching. It represents vapor pressure of pure liquid M, alright, and Raoult's law is obeyed from XL equal to 0 and X. This is actually in converse, right? You know, this is XM equal to 0 and XL equal to 1. So converse statement. So this is wrong. So this is anyways wrong. right? So the beautiful questions are asked. This is one of the best questions that I have seen in the recent times, right, from liquid solution. Like you would see the next question, that pure water is freezing and you are given the weight of the solute and weight of the solvent as well, and you know that the solute is non-electrolyte type where the molar mass is 46, and use the freezing point depression constant, that is the value of Kf. Now we know that for this you will get delta Tf equal to non-electrolyte type Kf into molality. So you got delta Tf equal to Kf is how much? 2 into molality, that is 34.5 divided by molecular weight is 46 divided by weight of solvent in kg, which is equal to 0.5. Alright, so when you do this, probably you will get the delta Tf as 3, as I remember the value. You can see that this delta Tf is 2 and 2 in these two cases, so only these two are possible. But you know that when you are freezing a pure liquid in comparison to its solution in a non-volatile solute, you know that the freezing point further decreases, and this is the solid solvent or ice that got separated. So absolutely perfect is this, but not optional. Alright, so hope you have enjoyed this session. Hope you have understood the concepts related to it. Keep watching. The physical and general chemistry sessions are over now. Now we need to emphasize on the organic chemistry part and then inorganic. I want you to follow these sessions and solve these type of questions either from what you call PYQs if you get any at this point of time, or you appear for as many mock tests as possible so that you can get some perfection in the concepts, right? And keep watching my videos without fail so that you can understand the concept better. That's it for today. See you again in the next session.